Hi, welcome to the video tutorial for the 14th Let's Think Secondary Science lesson, Does It Work? My inspiration for this lesson comes from this book, Bad Science by Ben Goldacre, and it's one I think all science teachers should read because it deals with public misunderstanding of science and how people in the press and how experiments you can't draw conclusions for them. And in the book he talks about the fish oil experiment that was carried out with some students in the north of England. The idea being that if you give students fish oil, can it make them more intelligent? Do they pass more exams? And that's one of the scenarios we use in this little activity. You know, does giving fish oils improve exams? And the problem with the experiment was they couldn't prove anything because it wasn't a controlled experiment. And so I think this is a really important reason why we need initiatives such as Let's Think Secondary Science, because we're challenging children to think about science not just in the classroom but connected to beyond the classroom. So the scenario that we start with is, how do we know if a treatment has worked or not? Because we're dealing with living things, we're dealing with real things, there's lots of variation. And we're using a word here, correlation, that children from the beginning of secondary school will misunderstand. There's a real confusion in children's minds over the lines we draw on graphs. And a lot of them, when you draw a straight line on a graph that's in science, it's a proportional relationship, such as Hooke's law, the children will say there's a correlation, because they get used to just drawing the points up with a ruler and saying that's a line of a fit, that's a correlation. We're actually here, we're using correlation in the sense of what is the strength of the relationship. Because in living things, so if you treat parsnips with Gro-Par, some of them will be bigger, but some of them won't, because we're not talking about having everything uniform for supermarkets. We're actually dealing with living real things here, and you will always get variation. So if you look in the one without treatment, some are bigger, some are smaller. So this first slide is just to get them to discuss, how do we know if it's had an effect? And to raise the fact that there are 4 possibilities here. And the 4 possibilities in this experiment are, with the treatment, it's had an effect. With the treatment, there's been no effect. Without the treatment, there's an effect. Without the treatment, there's been no effect. So in this activity, we want them to start comparing the ratio of what we would call proving cases with disproving cases. So if you have a look at the cards we use in this experiment, I'll talk a little bit more about that. This is the only work card with this activity. There are no ones at the end because we're hoping that current situations, events in your local area can lend themselves to a discussion in a similar way that we're wanting the students to think in this activity. So this lesson, really, this activity sums up the starting discussion before you give the cards out, because really it's a card sorting activity, and the end one is just preparing them to talk. So all the information in the orange box gives a focus for the discussion which you will need to manage and the children will need to run with and discuss and reach a conclusion. So in this lesson, because we're looking at the strength of relationship in situations where we're dealing with real and living things with lots of uncontrolled variables, we need to get the students thinking about the correlation as helping us focus on the strength of a relationship and describe and explore relationships. And we're bringing together two strands of thinking, correlation and ratio. So let's have a look at the hair product example. So if you have a look here, with the treatment we've got 7 positive effects. With the treatment we've got 3 effects that we don't want. But without the treatment we've got 4 positive effects and 2, 4, 6 without the desired effect. So some of these ones prove that the treatment works. So what the students need to do is combine them, and this is where the idea of the ratio comes from. We're going to combine the proving cases with the disproving cases. So in this one we've got 13. Let's check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got 13 cases that prove the treatment works, because with the treatment you've got the desired effect, without the treatment you haven't got the desired effect. And we've only got 7 that disprove it. So the ratio here is 13 to 7, which we could say is a pretty strong effect. But let's have a look at the fish oil example we've used now. Do you want to stop and I'll put the fish oil? So let's now have a look at the fish oil case, because what we're asking the people to do is look at 5 different scenarios. Does taking fish oil get better at exam results? Does putting product in your hair make it straighter? Does giving special milk to lambs make them bigger? Does giving parsnips grow power make them bigger? And also, does taking supplements make your muscles stronger? So there's interesting spin-offs you can explore here with your students. But we'll just look at the exam results one. The fish oil example is one that's on the borderline. So if you have a look at the cards split up into with the treatment, without the treatment, you've got 6 with fish oil tablets have done well, 4 haven't done very well. So they'd look at this and think, oh, there's more with the fish oil tablets have done well in exams than the ones who haven't done well after taking them. So it must work. But actually, if you look at the proving and the disproving cases, so the proving cases are without fish oil, you don't do very well. If you add them all up, we've now got a scenario where we've got 11 to 9. Now, the class need to discuss these. With all 5 scenarios, they need to come and look at the numbers and make a decision, is the correlation strong enough? So we've now got 11 to 9. Is that strong enough to prove that fish oil tablets are having an effect? I don't think it is. So the question then is, what could they do to find out more? What could have gone wrong? Was it the design of the experiment? And you could relate the real scenario that the students weren't monitored. It wasn't a fair test. So this activity lends itself to following a line of inquiry that your students suggest or that you suggest. So this is a very, very interesting use of maths in a real life scenario, one that many scientists will face. There's lots to discuss at the end of this lesson in the plenary reflection metacognitive aspect of the lesson. There's the individual results, where you collate the results on the board. There's the pupils' decisions over have they worked or not, and how do we know? And using the word correlation and comparing the 2 ratios and seeing if they understand that. Because again, we're focusing on them juggling many things in their minds at the same time and actually talking through proving case and disproving cases will result in a lot of children laughing, saying with the treatment there's an effect, with the treatment without an effect, and without a treatment there's an effect, without a treatment there's no effect. And saying that in these scenarios will be quite humorous. So once you've discussed the individual examples, you need to decide what numbers do we go with so we know there's a correlation and what aren't we sure about. And then applying it to a real life scenario, things that pop up in the press all of the time. So there's lots to discuss in this lesson, and it'll be really interesting if you upload, because on the website now you can upload your own examples, photographs, good ends to lessons. It'll be really interesting to see how you use this lesson in all your different schools.